Okay, so lesson 3, rapid application development, variables, constants, and some calculations. So we're going to talk about, in this lesson, we're going to talk about a bunch of different things. I think some of the key things that we're going to be discussing are things like converting from one variable to another. We're going to be talking about scope, okay, and what scope means from a C# perspective, right? We're going to be covering data types, okay, and again, we're going to talk the very simple variables. We're not going to go into complex variables. We're going to probably handle that later on in the course. We're also going to be doing some or discussing some error handling and message boxes. So we're going to kind of handle that this lesson as well, right? And error handling in the using try-catch kind of blocks of code. All right, very, very common way of error handling, and very common in terms of the way it's done across all C-style languages. So let's talk about variables a little bit. And again, if you haven't done any kind of programming in the past, I'm surprised. But variables are variables. They're places in memory that hold values, all right, if you will. They can also be more complex than that. And again, as we go on, we're going to talk about that. They're representations, fields, if you will, of data that we manipulate in order for our program to actually do something, right? So again, variables, we hold memory locations, hold data. Named constants are a little bit different than intrinsic constants. We'll talk about those as well. But named constants are a type of variable that we're going to define at the top part of our class. Okay, usually underneath the namespace. We're not going to do namespace variables because that's bad practice. We're going to talk about that as well, what those are. So we're going to name our constants, and then we're going to talk about the convention for naming them. And more or less those constants. And again, I kind of mentioned it here. You see, I'm showing you the conversion. So upper camel case for VB for naming conventions, camel case for C#, right? So again, because we're doing this course and it's a conversion course, right? If you used either one or the other convention, it's just a convention. As long as your code is human readable, I will be happy. In the real world, you're probably going to be pressed to use camel case though, right? The C# methodology. Just be aware. Okay. Declaration statements. When we talk, VB, who remembers the declaration type statements in VB? What do you do with VB? You use dims, right? Right. We don't need to do that, right? And var will work if you use it in most C-style languages. For example, in JavaScript, you use var, right? C-style kind of language. C++ and different other languages. Here, you don't really need to do that. It's assumed that var is in front of, or it's a variable as in front of your name, or the name of the variable. So here, an example is the way you declare a variable. You would have the name of the data type. So, example, this would be string, and remember, string in lowercase. There's different kinds of objects, right? It's not a string object necessarily, but because there is, and if you go into IntelliSense, when you start typing string, it'll give you two options: capital S or lowercase s. When you declare your variables, it's lowercase s. Okay, so string, and then whatever the name is. And if you notice, the second part of the variable, and this is a very common convention for Visual Studio and a lot of languages like this, is you name the type of the data type in the variable name. So, for example, a name string, right? Name is really what we're naming the variable. String is the data type. Why would we do this? Anyone have an idea? Yes.
That way you can quickly glance at the variable to know what data type it accepts.
Because if you know what type of information it accepts, if you will, what type of data type it is, you won't have typecast errors. Yes?
Yeah, I was just going to say that when working in my program, I was going to say the type of data is very important because even things like integer and float, they don't mix in C#. Like some programs, not easily anyway.
They mix, but you lose data. That's the problem. And we'll talk about converting, how to convert properly, right? But you're right. It'll cause issues, right?
Which is why casting is
the way to go. Yeah. So casting is the way to go, just to reiterate. And the great thing is about when we do comparisons, if you compare by accident, it'll allow you to do it in C#. If you compare a string with an int or something like that, an integer. but it can confuse people and it can cause other kinds of weird errors. Okay, so that's one thing. Int, again, would be the integer data type. And if you notice, we have a modifier, okay, an accessor type, if you will, in front of the variable when we create our constant. So we have const, that's the keyword used for constants. Decimal, that's the data type that we're dealing with here. And then, again, when you declare a name constant, the convention is to, put the name of the constant in caps. So discount rate, if you notice, they're in caps. Again, separated with underscores, because there is no camel case. That's the reason why we separate them. Okay? And if you notice, the last part of the word itself, the last part of the constant is it's in capital case here. And the reason for it is because this is just the data type. At the end, we have this 0.15 and an m. Who knows anything about why we need the m? There's a reason for it. And when we declare constants in general, we need to make the compiler aware of what type of data we're storing in the constant. M represents decimal data. We'll talk about those identifiers in a bit. Okay, so just a brief about what they look like when you start declaring variables. Okay, so if you notice, there is no var, there is no dim. I haven't said any of that stuff. And depending on where you declare the variable in C#, you're going to have access to different modifier keywords. All right, depending on what scope you're using for your variable. Example: if you're in the namespace, there's certain things that are going to be available. Like, for example, the other keywords like global. Please do not use global variables. Okay, global variables bad. Actually, global variable is bad. Period. Whether you're programming in C#, C++, whatever you're programming in, avoid them. It's bad programming practice. Okay. But in a class level, you have the option to use keywords like private, public, and so on. Right. So you're going to have other modifiers. But inside the local scope of, for example, inside a module, like for example, inside a method, right, a local variable, you cannot use the private and public keywords. They're not available at that level. Okay. So here's some data types. These are the data types that are available in C#. I kind of put it here in a little chart for you. And again, if you notice, there's bool, byte, car, and so on, and date time. That's one that's kind of weird, right? And there's also object. You can name a variable an object. And so what you're actually doing is you're defining it as a generic object type. And then you can recast it later on, if you need to, into the type that you need. So I need a generic blah, 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 whatever that blah, blah, blah is. I don't know what it is yet. And this is a great way of being flexible when you program. And right now it's an object, and if I take an argument, I don't know what type of argument I'm taking. I can cast the object into the data type that I need. All right, so you make sure your constructor is very flexible, and other reasons why you use that. Okay, so there's different things here. Some of them are very, very common. For example, I said there's .NET Common Language Runtime data type is next to it. So those common runtime data types, right, the CLR type, these are the ones that it pertains to. So Visual Studio has these variable types that when you declare a variable of bool in C#, it converts it at compile time to Boolean. Okay, believe it or not. Okay, same thing with VB and F#, whatever, all these different kinds of languages, right? It doesn't matter what language you're using for .NET, right? It converts them into this common variable set. Okay, so again, let's go back to naming conventions a little bit. Meaningful names. You're going to get ranked on this anyway, guys. When you make your assignment, you do your assignments. If you don't use proper naming conventions, and if I see X's and Y's and variables that make no sense, you'll lose marks, right? Must begin with a letter, right? Be careful with that. Sometimes you can, in some languages, it allows you to create, variables with numbers. I'm recommending to you, even if C# will allow it, please don't do it. Okay, it could cause issues. Cannot contain spaces or periods because period, first of all, space, the compiler won't know if you're talking about one variable or two. Spaces basically say this variable is maybe you're trying to declare two variables or you forgot a comma. The compiler won't know what you're doing. The interpreter won't understand things. So, so please leave out spaces. Make sure if you need a space between keywords or words in the variable, use underscores. That's a good way of doing it, or use camel case or upper camel case. Cannot contain periods because periods are the accessor type that we use in C# to access our methods and properties for our classes. So that's why it'll confuse the compiler as well, right? Don't use reserved words, right? Like, for example, string. Don't use that, right? Try not to use those in your variable names. And what I mean by that is you name a variable string, not string variable or something else. String or int. Don't try and do that. That's silly, right? It'll confuse the compiler. Actually, it'll give you a syntax error. It won't allow you to do anything. And variable names in C# are case sensitive, and that's the difference between C# in a large way and VB. VB is case insensitive, so you can name a variable, camel case, upper camel case, lowercase, uppercase. Doesn't matter in VB. It's all the same, right? In C#, it makes a difference, and it's also the case for JavaScript and other languages. They're case sensitive, so we have a much stricter variable declaration in C# than in some other languages. Okay, case sensitive. All right. And I kind of broke it out here between, I give you some examples of if I have a field of data called social insurance number, then you'd want to, kind of put social insurance number and the data type at the end, string. Again, if you were doing it for C#, your S in this particular case would be a lowercase letter, right? If you're doing for C# conventions. Okay. So, name constants. Again, you use a constant keyword. You assign a name, a data type, and a value. Usually those kind of things are the things that you need. And here's the way, this is the general form here, const, and then, the data type, the name of the data, the name of the variable, and then a value. And if you notice, again, for the decimal, we have that little finicky M that we put at the end of it when we're doing, we're dealing with constants. Okay? If you notice, it says, we have a bunch of intrinsic constants as well that are part of Visual Studio, and there's a good example of that would be your color, right? From lesson 2, remember we had the color black. That's a constant that's available in Visual Studio. That's part of the language. It's for C#, right? So when we assign values to constants, we use these type declaration characters, and you need to do this with constants, or it'll bark out a problem. It'll say, I don't like what you're doing here. So you need to use these. This isn't optional, right? For C#, actually for VB as well. Decimal, you need an M, capital M, or a smaller case m. You choose. And please, if you're going to do this, if you're going to declare constants, one or the other convention. I don't want to see capital M, lowercase m, capital D, and lowercase d all over the place, right? Whatever you're doing, stick with one, right? And here's an example. See how this is different? Right? This makes sense because L, you can't tell if it's an L or a 1, right? So I used the capital L in this particular case for a long, short, S or S, and here's a float 101.25F. Again, either one, whatever you choose to use, you need to use those when it comes to constants. Okay, again, general form is right there. We kind of talked about that. When you start typing a variable, and let's go to C# let's go to Visual Studio for an example. So I'm going to create a new project. In this case, I'm going to call it Lesson 3. And you can follow along here if you want. By the way, again, I talked briefly to some of the students last class. We were talking about Git integration in Visual Studio. And if you notice, I have an option here to create my new Git repository because I've downloaded a tool that allows me to do that. It's not part of Visual Studio. You can do the same thing. I'm not going to cover it though, but you can include it. And then if you click on that Create New Git Repository, it'll create a new Git repository locally on your machine, which you can, with some minor work, sync up with a GitHub online to allow you to do proper version control. Okay, so I'm not going to do that here. I'm just going to say OK. And again, I'm creating a Windows Forms application. Here we go. So So I've got a blank form, and you know what? I'm going to drop in a button. Why not? I'll put it in the middle of the form here somewhere. And if I double click on this unnamed button, right, I can start typing in here, and this is the actual event handler that I'm typing within. Okay, again, if I was going to look at the classes, I've got these using statements that basically drag in all the libraries I require, and you know, so I can access some of these basic components that are available to me. I could remove some of the ones that I'm not using. I could do that later on, but I'm not going to do that. And again, I've declared this namespace lesson 3, and the public partial class, which I spoke of this morning, what partial means. Again, partial means that the class has been broken out between more than one document. So it's also on the design side as well. And at compile time, both pieces of the partial class are combined to make a complete class. And then, so in here, under this partial class, here's where I would actually declare my constants and my class variables. Okay, so here's where I'm starting to define some stuff. And if I start typing, I don't have to. I can make it so that I don't declare anything. I start typing int, and if I start typing it, it'll try and pick out the one that makes more sense. So as I type, IntelliSense will come up with the data type, different data types, to try and understand what I'm trying to do here. All right, or I could do something like const. There it is. And if I hit enter, const is lowercase. Then I can put in decimal. So I'm typing it in. I can hit enter. It'll put it in properly. If you notice, when I'm typing in Visual Studio, IntelliSense will make my text editor. It'll change the colors of the actual keywords and change them to blue. In my particular case, that's depending on the theme that I've chosen, right? So my theme is this theme. Your theme might look different if you've chosen a different theme of colors and so on for your Visual Studio. But if you notice, it's not complete. I've put in a modifier, const, my decimal, which is the data type, and now I'm going to name my constant. And again, from a convention perspective, I want to do something like my constant, and maybe I'm going to make it decimal. Okay. Now I have to define it as something, and usually when I'm doing, if it's a decimal, maybe I'm going to make it 0.01 m, and then end it up with a semicolon. Okay, so this is a first type of declaration. This is a constant that's available at class level. So we're going to talk about scope. This means that it's available anywhere within my form, my class itself. This class that's called form1. Okay, this partial class. Okay. So that's one thing that you know, we're starting to define stuff. If I want to define a variable that's only available to my class and not available outside of my class, I start typing. And if you notice, the private keyword comes up. So private, let's make it a decimal as well. And then this time I'm going to define it's not a constant, so I'm going to use you know, different type of convention here. So I'm going to say I'll say my my private. I'm going to call it my private decimal. Whatever. You can call it whatever you like. And then I'm going to call it 0.10 m. And I don't have to put the m here. If I put this, if you notice, even when I'm defining decimals, if I don't put it, what is it asking for here? It's sort of saying, hey, there's a problem, right? It says literal of type double cannot be implicitly converted to type decimal. Use an m suffix to create a literal of this type. So it actually gives you the error right here. If you don't know what you're doing and you say, hey, I left out my m, you know, it'll complain, right? You can turn, by the way, you can turn these errors off if you don't care about them, right? Visual Studio is very, very flexible, so you don't need these errors to be turned on. However, I recommend to you that you don't, I mean, they won't run, right? But you could control it so that you turn these errors off. So let's put the m in there. Again, we're staying with the convention of using lowercase m's. Yes?
Why is it that when you create a double constant, you don't have to put the...
Because it looks the same. It's what they're trying to do is, you remember when I am assigning, when I use the equals operator, what am I doing? I'm actually I'm assigning, and when I start typing 0.10, how does the computer know what I'm talking about? Right? It doesn't. It thinks I'm actually, if I put 0.10, it thinks automatically it's a double. Right? So if I don't tell it otherwise, the value on the other side of the equal sign, it doesn't know. So I have to cast it. Now, here's another way I could do it. If I don't want to do m, right, could I do this? Could I go decimal, right? and cast it. Is that okay? That's okay, right? That's the exact same thing. If I put M or I cast it like this, both are good, right? Because I'm saying I want to take this number that I put, this literal, which is 0.10, and there's a difference between a literal and a variable. I'm defining this literal 0.10. I'm also telling the computer, forget the other, the precision behind it. I don't care about it. I'm going to make it a decimal, and I need to cast it somehow. The M is a short form of how to do this. That's all it is. So you don't have to put this whole brackets, casting, blah, blah. Okay? Let me just take that back. So actually, I'll leave it like that. I can also, if I go in here, what if I start typing other words here? If I go, I can also do public, right? Public decimal, right? And then my public decimal. And let's say that's equal to 1.10M, right? That's also possible. So there's 3 different keywords here I'm using as modifiers to my variables. And it's done here at class level, okay? I'm using const as a constant, private, you can guess what that is, and public, right? Why would I use private or public? If you guys remember anything about object-oriented programming in any language. Yes?
Public would be accessed across the whole program, and private only the class that it's in.
Private is like protected. If you've ever heard private or protected,
Can't be changed by any external source.
it's got to be inside. You have to use getters and setters to do it properly, right? That's what private means. It's almost like that's where the encapsulation of the object-oriented programming concepts come from. You have to use private variables, right? Public variables, they're available outside of the class. You can access them once the object is created. And what's my object? What object am I creating here when I instantiate my class? Yes. The form itself is the object. It's a combined set of other objects, right, that we have used. Because remember, every control is an object, right? So I'm using my controls. I'm casting these objects, right? I'm creating them. Poof, they exist, right? And I'm putting them as components, adding them on, slamming them into the form. So I have this one big object that I'm creating. And when I launch my code, I've instantiated that object, and it becomes the form that I'm seeing. This fully functional interactive form. Okay. So I know we kind of stepped ahead a little bit, but I wanted to kind of show you that. And again, this is IntelliSense tells us how to get all that, and it'll write some of this for us, right? So if you don't know how to do something, you don't know what you can't remember, as an example, because we're switching from one language to the other, and sometimes one type of variable, you don't know if it's a capital you have to use or a lowercase. IntelliSense will help you do that. Because guys and girls, chances are you're not going to be writing you're not going to use one type of language in your coding lifetime, right? The lifetime of you being a software developer, coder, whatever, you're going to be shifting. Maybe today you'll be writing in, Objective-C. Tomorrow it's going to be Java. Third day it's going to be something else, right? You never know where your career is going to land you. That's what I'm saying. And you're probably not going to remember all the conventions of every syntax of every kind of language you're going to be exposed to, right? So IntelliSense and code hinting and other IDEs helps you with that. Okay. Namespace, again, also called global variables. We're talking about scope here. It may be used in all procedures, methods, right, or classes, if you will, of the namespace, which is generally the entire project. Class level, also called module level, you might see that across different writings. Again, we're doing this conversion, right, are accessible from all methods of a form. And local may be used only within the method in which it is declared. Block level, again, there are some times we use block level. For example, inside a for loop, we have a block level variable that we declare, right? So there's block level as well. Different variable scope, again, I'm just going to touch on lifetime. You should know this already if you're a coder. The variable lives and dies, is born and is destroyed, if you will. Garbage collection happens, let me put it forward even more, automatically, right? When it's born and when it dies, it gets created, instantiated, and destroyed, right, within its lifetime. So if I have a variable that's namespace, it lives as long as my project is alive, right? Think about us being inside the matrix, right? I have an avatar, and she's with me. If I make an avatar, it's a beautiful girl, right? It's namespace avatar. She'll be with me the whole time, right? Maybe that's a bad thing, right? Anyways, but if I have her and she's a class level, she's only going to be with me for the, the time the class is, or the object that I've instantiated from the class is alive, and so on. Maybe that's a bad example, but you get what I'm saying, I think. The Woman in the Red Dress program. I like that. There we go. We'll add that into the video. All right. So here's examples of local declarations, and I got examples here in my slides. And if you notice, you've got your private. When I'm creating my, when I'm double-clicking on my form on my control, it creates this little stub, okay, which is my event handler, right? Usually it has nothing inside of it, right? And in Java, you might see to do, do this, and enter some stuff in here. It's empty, right? Well, anyways, so it says, I put in a little comment, calculate the price and discount. Here's my int, quantity integer, and again, this is using upper camel case from VB. A decimal, and I've actually, separated with commas, I've actually declared a bunch of decimals here, right? And I haven't given them any values, but I've actually declared them. Here's my variable declaration. And this is inside my event handler. So this would be a local declaration. These variables here live and die. The woman in the red dress, she lives and dies inside this local declaration of this event handler, all right? Then she's gone. She disappears. And the next time I call upon her, she won't remember me, because she'll be a new woman in a red dress. I'm instantiating her yet again. Okay. Class level, same kind of idea, except we're allowed to use these different modifiers. And again, I said use public or private as best practices, right? When you declare keywords in the class, do you have to do it? The answer is no, but you should. You should tell the compiler, if it's a private or public type of variable. All right, and so here's an example const. We just did this, and private here, and I've given it a quantity 0. And the reason why I don't have to put something in here is because 0 is an int, right? It's okay, right? Okay, so here's an example. I'm just giving you the kind of a more of a general form. So namespace variables, right? And if you notice, inside the namespace, you have your public partial classes at the top, your private. And inside here, you have your private event handlers and methods inside of the class itself. Okay, and it's kind of broken out where what do all the variables mean? A variable scope. So block level isn't as common, and again, you can do it. It means you declare a variable within the braces, right? The curly braces. Okay, it's not very common. Usually we don't do it that way very often. It's, again, it would be the time that it would live and die is very, very small. There'd be specific reasons you want to kind of create a block level variable. Again, mostly it's done with loops for sentinel variables that are controlling loops, and for example, like the for loop, right? Namespace level, I recommend highly do not make these happen in your code. In fact, I will not be showing you how to do it. If you need to find out how to do namespace level variables, learn it on your own, right? Because I don't want you to use them. I want you to avoid them, right? Don't use namespace level variables. Okay. Yes, it might be irritating to some of you saying, why? I want to know how to do it all. Well, you know what? I'm sure your Google foo is strong. Yes?
They have these abilities, but why do they even have it? Everyone, like public variables.
Sometimes you have to get around, you have to go around a problem that you can't fix. You don't understand how to do it, or your convention might require you to have a public variable or a namespace level variable. There is something else that's greater. You're accessing, you're using it for the greater good. Okay, I'll put it that way. There's a reason why it's required for the type of format or class or structure that you need, and usually it's done because they haven't figured out a way to do it without. Okay, typically, I'll tell you right now. So we don't use them typically. All right, calculations. Let's see, we're sitting at 10:47. We'll run a little bit more for calculations, and we'll stop at the next little juncture. All right. So how do we do calculations? Again, we can't use strings in calculations. I kind of talked about that last time, and if you've worked on assignment number 1, you know you have to cast anything that you get from the input string from a control. You have to cast it into the variable that you need. Right, so we'll talk about how to do that here. because we must convert a string into a numeric data type. So let's talk about how we do that, right? Well, there's these common methods. If I'm converting from string into an integer, I'm going to use the int.parse method. And for example, there is usually a .parse for most of the data types that are out there. Okay, so if I'm going to go from string, and this is the most common, to int, I'm going to go int.parse, and then the conversion is going to be integer. If I want to from string to a decimal, then the conversion is going to be decimal.parse. So I'm going to use that method, right? The parse method of the data type. Okay? Because remember, it doesn't matter if it's an int, it doesn't matter if it's a decimal or a float. Each of the data types, even though they seem to be simple data types, they're actually objects. And each object has methods. So you can use the .parse method of every object here when you're converting from string to the data type you want to go to. And these simple data types we're talking about, yes?
I don't know if you cover it, but there's also the one I've been using is try-parse.
Try-parse?
Far more powerful because it has built-in error catching. So
that's, yeah, so we're going to talk about without error catching inside. You're right, there are data types and there's different methods you can use that do that. But my question to you is, do you trust the error catching? Will it catch the type of errors? Can you specify, the type of errors you want to do and the type of messages that come back? And chances are what's that?
Well, the way I do it is I have it built into an if statement. So
okay.
If try-parse, then it'll output an error, which gives it false, and then I have an error message.
Right.
If it succeeds, it sets the variable, and then I continue on.
I love this. This is Google Foo at its finest, right? Yes, you can do it. If you know how to do it, there are different methods, definitely stronger than these ones, right? But I'm showing you the basics that you would need if you're going to, basic components you need to do what you need to do. And we're going to talk about, we use our try-catch blocks to do that error handling a little bit differently, okay? But I like your thinking. The same thing with the two strings. So if I have a decimal or if I have a numeric type variable and I'm converting it to string, then I got to use the toString method of my data type. Okay, that's what I'm doing. So I'm applying the toString method, and here again you have some examples of I'm converting input values that were originally string values to numeric data types. I have to use this int.parse or decimal.parse. You're going to need this for your assignment number 1. Guys, if you have, please look carefully. You're going to say, what was that method that Tom was talking about? Well, you can look it up on the video anyway. So converting to string, here's again the example. So I've got my result textbot.text, and I am converting to a decimal. So I'm going to say my result decimal to string is what it's going to be equal to, right? And that's how we do it. Okay. So if my result decimal is a decimal, and I want my text box, right, which is a string, to take on its value, I've got to convert it first before I assign it with my assignment operator to my text box. If I don't do it that way, you're going to have an error. It'll complain. The IntelliSense will say, meh, you're trying to convert a numeric variable to a string without casting. What are you doing? I don't understand. Okay. Arithmetic operations. Again, what are you going to do? If I want to add something, I'm going to use the plus, minus, multiply, divide, and the percent, which is the modulus, the remainder of division. In some other languages, VB is an example, you have the div keyword for modulus. But most C-style languages, you have this percent sign. That means I want to convert, get the modulus, the remainder of my division. You can also use, for experimentation, if you notice, there is no exponent. Remember, in some languages you have that caret, right, that you can actually say this is an exponent 5 or whatever. There is no exponent in C#. You have to use the math library for PAL, the PAL method of the math library, and you have to kind of include or use the math class, which we'll talk about later on in the course. If you want to get more into it, you can also look it up with Google and MSDN. Okay, order of operations, very similar to what you learned in math, but just as a refresher. The first thing you look at is anything inside parentheses, then multiplication and division, then modulus, and then addition and subtraction, right? That's the order of operations. If you want to kind of work out the result of your arithmetic statement. Okay, and here's some math examples which I'm not going to go into. Using calculations in code, you can also use these short form operators to do the same kind of thing. For example, instead of saying total sales decimal is equal to itself, total sales decimal plus sales decimal, you can just do this whole thing that you see in other languages, which is total sales decimal plus equals to sales decimal, which means take sales decimal and add it on to total sales decimal. That's what it means. That's what that notation is referring to. And you're going to see that again in Java. And by the way, they're all taken from C, right? So that's why it's all very common. And I'm sure you've seen it by now, but if you haven't, here it is. Similarly, if you notice, you can also do with strings in C#, right? So if you take a string and you say plus equals to this string, you'll actually take the original string and concatenate the other one. Okay, so pretty cool thing that you can do with strings in C#. Okay. We should talk about the increment and decrement operators because they're very common in other C-cell languages. Again, count integer plus plus, right? And count down integer minus minus, right? What do they do? And what happens when you put I said it here already, if you put the notation, the plus plus or the minus minus on the back, on the end, or on the beginning, prefix or the suffix, if you put it on the prefix, or so-called prefix notation, right? Here it is, plus plus. It adds the value before it does anything else, right? So, example, this would increment count integer by 1, and then subtract it from 100, okay? Whereas if you do postfix notation, which is, the other one, count integer plus plus, it would subtract it from 100, then increment it by 1. Okay? Again, different controls, and there's different reasons why you would do that kind of thing. But the structure exists for it to help you solve different kinds of problems that you need when it comes to counting. Okay. And we're getting closer. I think we've still got time. Let me see where we're going here. Yeah. We'll get a few more slides before we break. Okay. Converting between numeric data types. Again, if in C#, you can convert from one or the other. There's implicit automatic conversion, which, by the way, I don't recommend. Please don't do that ever, right? And there's explicit conversion, which is casting. And I think that's the way to go, all right? Now, when we cast in C#, so I expect you to cast. Obviously, I'm just mentioning implicit because it's there. You need to put again, I showed you already earlier, you need to put the type of variable that you're casting to, right, and then the name of the variable that you're casting from. So if I'm saying my number decimal, right, I want this number float to be shortened, right, cast into a decimal. I put the decimal in front in parentheses, and then it automatically converts. What happens here, though, when you convert from a bigger decimal, like a double or a float, to a decimal? What happens? I lose precision. Yeah, it just gets lopped off. I hate to say it that way, but I want to give it to you guys like it is. Imagine it gets lopped off. Okay, that's what I'm talking about.
So does it do truncation, or does it just drops off?
Lops off. Right. And the reason why I'm saying that is because, and I hate to say it that way, because sometimes you expect it to do certain things, like rounding, right? It doesn't do that. So you get unexpected results. So be careful when you do this casting, right? You may want to do other operations first, rounding as an example, before you cast, right? Because it actually truncates the data, it gets rid of it. Okay. There's also the convert class that you can also use. And again, you can say, I want to convert to decimal or to single or to double, right? There's also that option as well in .NET. And usually it's for integers, okay? So here's an example of how we can do it. We use my number decimal, and I say I'm going to convert to decimal my number single. So I'm taking the single argument, the single number, which is a smaller number, and I'm up converting it to a decimal. That's what I'm doing it, right? I'm taking a double, and I'm down converting it, right, to an integer. But if you notice, I have to use the int 32 when I convert to an integer, right? And there is a long list of stuff, and I'm going to go just schmarn to it in a second, right? unlike data types, what they do with it. I'm not going to talk about that too much, right? But more or less, what you want to try and do is round before you convert. Okay, you don't want to convert and then round. That would be bad, right? If you're going to round at all. So here's an example. I'm going to round. I'm using my round function or method, if you will, of the data type, right? I'm going to put the decimal value, whatever it is, and I'm going to say the integer number of decimal positions. So how many decimal positions do I want? If I want 2 decimal positions, 1.455 gets rounded to 1.46. So it rounds up. Okay? And there are other functions that exist. If you look through and you Google it, there's all kinds of other rounding and different kinds of mathematical functions you can employ if you want a different result. Okay, this is one of the simplest ones. Okay. We're going to pause here before we go formatting data for display. And I'll give you guys a chance to get your coffees and any other food you want. If you want to eat pizza again, you can go ahead in the morning. Do what you have to do, and we'll be back in 10 or 15.